Alright, this is Mike rolling with that handle I got on YouTube and on the group list is Brother Mikey's cap dump circuit, for those of you who just stopped in. But I'm here to give you guys an update what's going on. Alright, I got that big cap dump in the mess here. You see that bank of caps? And I cut the head of it off. Here, let me move this. And it's on a hinge. You see the hinge right there? I can flip this head back up now. And oh, see my new wires? They got a switch here. I got to show you so many things. We're going to get back to the dump here in a second. Right below it, you'll see the circuit. This is my little driver circuit. I got it unhooked right now. It's, you know, your duty cycle and your timing. And it works, but the steering for something like this on a FET is okay for low power stuff, but you need more accuracy, I believe, because I just overdrove another FET. Of course, I did a lot of other things too that was wrong, that was overdriving the FET. But I want you to see this switch too, so let me tell you this, show you this. See those little alright, you see those little lever like things that pull up? I can disconnect it. I can disconnect both of these right here and put them up there. There's two up here. So I can push this up. They're blades. They're blade connectors. See them there? So I got a whole row of them here, 4, which makes for 12 parts. You have the pivot with the finger on it, and those fingers came out of something that was already made for this type of thing, out of an old rotary switch for a 3-phase welder, one of those great big ones you can fit in your wheelbarrow. Great big welder. And I made this switch. Well, this switch just lets me go between the two 12-volt batteries. Here's a 12-volt, you know, red and black, and over here is red and black, right? So I got two 12-volt batteries, but I can wire it up to 24 when I'm charging by just flipping the switches over, and then back down for the inverter or whatever I want to do there. I got these big lugs on here. You see those lugs where you can put a wire in there and tighten that nut right there. See those nuts on there? Those blade, flat blade screwdriver tightens them, and you put your wires in there. So this is quite a lot of fun here to do. But now that block of, well, it looks like plastic, but it's that block that I got it all on has to be insulated. So what I did was I took some glass plates from microwaves, because I'm an appliance dealer, and I took the glass plates and put them in a cylinder, a big 10-inch diameter cylinder, 1 foot tall, 2 foot tall, about 1.5 foot, and then I pounded on all the glass and ground it to bits into powder and sifted it. Then I glued that back together with epoxy. So this is glass epoxy, you know, resin with glass powder, borosilicate, high temperature stuff. And that's what I poured that block out of. Then I can drill it and all. You know, it's easier to drill if you got it all ground up into powder. And glass sticks to glass really good. For those of you who want to pour some glass blocks, it really works good. This stuff is tough. You can see that the face of it is painted a little white, but where I cut it again on the edge, you can see the brownish color. That's the color of like any fiberglass. But this is epoxy resin. Okay, now back to this. Now here's my circuit. I got to get this out of the way. Excuse me. And here's the top. I haven't pulled it up and down that much, but I wanted to show you, well, of course you know I'm hanging a meter on the side here. I bought a meter that's got a shunt, so I took the shunt and the meter, put them together so I could hang it around places. These seem to be a lot more accurate than just a panel meter without a shunt. Excuse me. Okay, so let's pull this up. Now here's the head of it. I got it where, I have to back up here where you can see it. See the machine there at the bottom, and then the head of it moves. See if I can reach over here and show you. That can come up and down, right? And my meter's on the top, and so I can get into the electronics. Well, the electronics goes in here. Here's the electronics right now I'm working on with the fan. That goes in there, right? Let me get the, I don't have long enough arms for this shot, but let me flip that back over. Sorry about the camera flying all over, but I can't wait another day and set up a tripod. I got to show you guys what's going on. Okay, there's the electronics on the top. That mounts. That mounts on these little. Whoops. It mounts on these little posts right there. Well, they call them standoffs. You see those standoffs? Right there. They sit on those little pedestals, like that. And it goes the other way. The fan. The fan side goes this way. Then when I shut the door, you'll see a fan port in the back, right back here. See it back there? And the air goes out that side. So you can see that this thing closes down on it. It's not all the way closed down. So it's coming along. I'm learning ways to work on it and things. And so what I decided to do was to install larger FETs, or well, I should say higher voltage FETs. Instead of 200 volt ceiling, I got a 500 volt ceiling, which lets me pulse and higher volts, and the reflected voltage that's multiplied sometimes does not burst my part. Well, generally I'd been using 6 of them, so I decided I'm going to use 3 and, you know, drive them up there. And I was using 3 of these FETs here, and I had to pull one already because after about, I don't know, 3 or 4 days of using it and overdriving it, just so you guys get an idea what I did. Excuse me. I took those FETs, those 3 FETs, and used all of these caps right down here to fill them with this power supply over here. I don't know if you can see it. This is a big thing. This has got a big variac on it. And this is my messy room here. And I feed it through this resistor can. See that can right there with the air? Well, there's a fan down below, down under here, and it blows upward. And the hot air comes out here. Well, whatever little bit of heat it produces, and in that way it keeps the resistor, which this is a resistor, keeps it at a steady amount and keeps it from building up heat. And then I show my amp draw here. Well, anyways, I feed in the caps with a regular current through this resistor, and so that creates an RC, a resistor capacitor charging timing. So you have a time that, and when it comes on, you'll see this needle is bouncing up and down, bouncing up and down. Well, I'm showing you right now that I got it apart. See, just 30 minutes ago I took this apart and I found out which FET it was by taking the 3 legs off of each one and seeing which one had, well, one had 62 ohms of resistance across it, which it should not be on a switch. It should be, if it's an open switch, there should be no resistance. And so I ran these really hard, and it's 100 degrees out here in Kansas, and I had that fan running, and I had a 12-volt battery, right? And I really wanted to know what my upper limits were, so I was pulsing at 25 volts for a few days. And then I don't really know, I don't trust the steering either. In other words, the guys all talk about how your driver circuit, your trigger for your FETs, if they're sporadic or whatever, if they're not firing each gate evenly, or if it's irregular, you're going to waste energy and you're going to overheat FETs, right? Especially at the higher power levels. And that's what I think a lot of people miss. These are high power levels. So I start out small, and what I have is I have all these hooked to a blade that I solder on there like this, and one wire fits across there. Well, in the end there's going to be like 4 sets of these 3, and then they go down to like this where I took them off from. See these connectors right here? These are big, heavy, like battery connections like you'd find on your great big tractor or lawnmower, big one. Anyways, so I didn't have any resistance, you know. I'm not using gator clamps. That's what I'm trying to say. And there's 3 14 gauge wires going together there, you follow me, and 3 14 gauge wires going together there, in and out, on pulsing the negative side. Well, you're only supposed to, and then we'll go to my Variac here system. You'll see over here, let me get this thing rocked back so you can see it maybe. You see the markings on there? I've got, what is it, 12 volts, 30, 40, and it goes up. It goes all the way up to 100 volts if I want. And this is DC. You see the rectifier on the side here maybe? I don't know if you can see it. I showed this before. There's a rectifier right here. And I got a hose coming up at the bottom. It's dark in here. And it's blowing heat, you know, and I got a fan in the back, and I keep that cool. Well, I got a toroidal down there too, the bottom inside the charger, and another toroidal here that's a variable toroidal. So anyway, charging the 12-volt battery, right? And I start here, and then I'll hook it to my pulse machine, and I'll run it up to about 25, maybe 30 volts sometimes, and pulsing it 1 per second. But what I did was I took those 3, which I knew it wouldn't last, and I ran it up to find the upper limits of these parts. First I started at 30, then I went to 35. Now keep in mind that my battery bank is 50 feet away in the basement. So I'm going to have some voltage drop, right? So I figured, oh, I'll just pulse it higher for now and just let it run for a few days and see what kind of pulsing effects I have on my battery. And every day I'd come in here and inch it up a little more. I'd go to I was all the way up there to 60 volts, guys. I know that sounds shameful, and it is, but I'm testing right now. See that dial there where it says 60? That's where I had it. I was hitting the battery 3 times a second with about 10 amps at 60, you know. So I'm running like at least 500 watts through there on 3 little FETs, and it just couldn't take it after a couple of days. Now I have plans to put 12 of those in there. See the upper screws? I got 3 in there now, or pulled one. See the one I pulled there. But there's 3 goes up here too. I just want to see what 3 of them can do. And then there's 3, and there's 3 of them over here. Now, the point is I'm going to take these same 3, I'm going to put them back together, only I'm going to use a different driver circuit, and I want to see how much better the driver circuit, the new driver circuit, is on the FETs by comparison. So that's where I'm at right now, and I'd like to share more with you. I gotta go to work, but there's the thing I'm gonna be working on this weekend. I'm gonna take this and I got all the parts for my 594, my TL 594, and my TC 4420 driver, and I'm putting that together, and I'm going to use that. Now, I don't know what in the world's going on sometimes. I'm new at this, and I heard a pop noise in my 5.5 timer circuit, and I thought, I wonder if it's a, I wonder if that was a cap. Where is that thing? Yeah, here it is. I thought, well, I wonder if that's a cap. Here it is. And I got these controls here. And I have abused this thing, you know, as far as of hooking it up, maybe, I want to say wrong, but for those of you who understand regulators and so on, here's a regulator section right here. So I have 2 grounds. This is not a ground. This is, well, let me get it behind something white. Here we go. You can see better. This has a ground here coming out of the regulator. At least that's the way I'm learning and exploring. You know, you have your feed ground right here, and then you have your regulated ground right here. And then I had this transformer right here that I hooked it up backwards one day. Now I'm not hiding anything from you guys, all right? I'm a beginner, and see that melted spot on the transformer? That's just a suppression transformer you find in a lot of devices that lets the power go in and out that way. Well, I had it there just to suppress any transients, but that's what I was thinking. But one day I hooked up the red and the black backwards, and it started smoking, all right? Which is okay. I mean, I can throw that away as long as there's no resistance. I can jump it across. And then I heard a pop from the circuit one time, and I'm looking at my caps. I'm thinking, I'm going to have to pull these caps out and check these. One of these is blown, I think. And the thing still works, right? So you see, I'm still trying it with that piece of junk. And I'm thinking, where'd that pop come from, right? So your driver circuits can get beat up and abused and do freaky things to your FETs. And these are brand new 460s. Cost me a whole $1 a piece, right? Wow. That's no big deal. If you were to go to college to learn this stuff, they burn up government paid schools. They burn up thousands of dollars in equipment and machines. So this is a great way to learn, you guys. And I'm going to keep showing you what I found. I found some of these caps that I built this little timing circuit out of old circuits. They're not new. I mean, none of this stuff is new. But now the next circuit is. I bought all new stuff, which wasn't much, and I hope to not hook it up backwards, this new one, huh? Because it ought to go up in smoke. It really should have, but because I had that suppression transformer in there, saved the day, it just started smoking, and I should have reverse protection. I should have do a lot of other work, but anyways, I drove this so hard that these 3 FETs at 700 watts, 700 watts max or more sometimes, I run it right up there, and this funky timing circuit, which was probably steering all over the road, back and forth, wasting energy, heating up my FETs, still hung in there for days. Okay, where the other parts wouldn't last 10 minutes or 20 minutes. The 250s, the IRFP 250s. These are IRFP 460s, which are capable of a lot higher voltage. So I just wanted to give you that update and talk to you again, you guys on YouTube. I know I'm forgetting something to share, but I'll be back to show you my progress here when I get it back flashing, because you wanna show this thing. I want to show this thing working as well as when it's broke down. Alright, till then, see you next time. Brother Mikey. Brother Mikey's cap dump circuit in progress.